V-1 flying bomb. The V-1 flying bomb was an early cruise missile. Its official Reich Aviation Ministry designation was Fi-103. It was also known to the Allies as the buzz bomb or doodlebug and in Germany as Kirschkern or Maikäfer. The V-1 was the first of the Vergeltungswaffen, V weapons, deployed for the terror bombing of London. It was developed at Peenemünde Army Research Center in 1939 by the Luftwaffe at the beginning of the Second World War, and during initial development was known by the codename Cherry Stone. Due to its limited range, the thousands of V-1 missiles launched into England were fired from launch facilities along the French, Pas-de-Calais, and Dutch coasts. The Wehrmacht first launched the V-1s against London on 13 June 1944, 1 week after, and prompted by, the successful Allied landings in France. At peak, more than 100 V-1s a day were fired at southeast England, 9,521 in total, decreasing in number as sites were overrun until October 1944, when the last V-1 site in range of Britain was overrun by Allied forces. After this, the Germans directed V-1s at the port of Antwerp and at other targets in Belgium, launching a further 2,448 V-1s. The attacks stopped only a month before the war in Europe ended, when the last launch site in the Low Countries was overrun on March 29, 1945. As part of operations against the V-1, the British operated an arrangement of air defences, including anti-aircraft guns, barrage balloons, and fighter aircraft, to intercept the bombs before they reached their targets, while the launch sites and underground storage depots became targets for Allied attacks including strategic bombing. In 1944, a number of tests of this weapon were apparently conducted in Tornio, Finland. On one occasion, several Finnish soldiers saw a German plane launch what they described as a bomb shaped like a small, winged aircraft. The flight and impact of another prototype was seen by Finnish frontline soldiers. They noted that its engine stopped suddenly, causing the V-1 to descend sharply and explode on impact, leaving a crater 20 to 30 meters wide. These V-1s became known by Finnish soldiers as flying torpedoes. Design and development. In 1935, Paul Schmidt and Professor George Hans Madelung submitted a design to the Luftwaffe for a flying bomb. It was an innovative design that used a pulsejet engine, while previous work dating back to 1915 by Sperry Gyroscope relied on propellers. While employed by the Argus Motoren Company, Fritz Gosslau developed a remote-controlled target drone, the FZG-43. In October 1939, Argus proposed Fernführer, a remote-controlled aircraft carrying a payload of 1 ton, that could return to base after releasing its bomb. Argus worked in cooperation with C. Lorenz AG and Arado Flugzeugwerk to develop the project. However, the Luftwaffe declined to award them a development contract. In 1940, Schmidt and Argus began cooperating, integrating Schmidt's shutter system with Argus atomized fuel injection. Tests began in January 1941, and the first flight made on April 30, 1941 with a Gotha Go 145. On February 27, 1942, Gosslau and Robert Lusser sketched out the design of an aircraft with the pulsejet above the tail, the basis for the future V-1. Lusser produced a preliminary design in April 1942, P-35 Effort, which used gyroscopes. When submitted to the Luftwaffe on June 5, 1942, the specifications included a range of 299 kilometers, a speed of 700 kilometers per hour, and capable of delivering a 500-kilogram warhead. Project Fiesler Fi-103 was approved on June 19, and assigned codename Kirschkern and cover name Flachzielgerät 76. Flight tests were conducted at the Luftwaffe's Erprobungsstelle Coastal Test Center at Karlshagen, Peenemünde West. Erhard Milch, State Secretary in the Reich Ministry of Aviation and Inspector General of the Air Force, awarded Argus the contract for the engine, Fiesler the airframe, and Askania the guidance system. By August 30, Fiesler had completed the first fuselage, and the first flight of the Fi-103 V-7 took place on December 10, 1942, when it was airdropped by a FW-200. Then on Christmas Eve, the V-1 flew 900 meters, 1,000 yards, for about a minute after a ground launch. On May 26, 1943, Germany decided to put both the V-1 and the V-2 into production. In July 1943, the V-1 flew 245 kilometers and impacted within a kilometer of its target. The V-1 was named by Das Reich journalist Hans Schwarz van Berkel in June 1944 with Hitler's approval. Guidance system. The V-1 guidance system used a simple autopilot developed by Askania in Berlin to regulate altitude and airspeed. A pair of gyroscopes controlled yaw and pitch, while azimuth was maintained by a magnetic compass. Altitude was maintained by a barometric device. Two spherical tanks contained compressed air at 6.2 megapascals, 900 psi, that drove the gyros, operated the pneumatic servomotors controlling the rudder and elevator, and pressurized the fuel system. The magnetic compass was located near the front of the V-1, within a wooden sphere. Shortly before launch, the V-1 was suspended inside the compass-swinging building, Richthaus. There the compass was corrected for magnetic variance and magnetic deviation. The RLM at first planned to use a radio control system with the V-1 for precision attacks, but the government decided instead to use the missile against London. Some flying bombs were equipped with a basic radio transmitter operating in the range of 340 to 450 kHz. Once over the channel, the radio would be switched on by the vane counter, and a 120-meter (400 feet) aerial deployed. A coded Morse signal, unique to each V-1 site, transmitted the route, and impact zone calculated once the radio stopped transmitting. An odometer driven by a vane anemometer on the nose determined when the target area had been reached, accurate enough for area bombing. Before launch, it was set to count backwards from a value that would reach zero upon arrival at the target in the prevailing wind conditions. As the missile flew, the airflow turned the propeller, and every 30 rotations of the propeller counted down one number on the odometer. This odometer triggered the arming of the warhead after about 60 kilometers. When the count reached zero, 2 detonating bolts were fired. 2 spoilers on the elevator were released, the linkage between the elevator and servo was jammed, and a guillotine device cut off the control hoses to the rudder servo, setting the rudder in neutral. These actions put the V-1 into a steep dive. While this was originally intended to be a power dive, in practice the dive caused the fuel flow to cease, which stopped the engine. The sudden silence after the buzzing alerted listeners of the impending impact. Initially, V-1s landed within a circle 31 kilometers in diameter, but by the end of the war, accuracy had been improved to about 11 kilometers, which was comparable to the V-2 rocket.